I don't know about you, that's kind of a nice way to start a video, some nice swirly blue stuff. That said, don't know if that had really anything to do with the equilibrium, just looks neat. Anyway, here we go, second calculation dealing with determining equilibrium concentrations given a value of K and initial concentrations. And the difference here is that you're going to have to use the quadratic formula. And so the quadratic formula I think you're familiar with, and so you just have to use it. And there's no two ways around it, so you might as well just, once you've identified that you need to use it, just get your handy dandy calculator and do things very carefully. So there's a question to calculate all three equilibrium concentrations given a value of K and given an initial concentration of phosphorus pentachloride of 1.0 moles per liter. So there's our equation. First step, as always, is going to be our ice table. So let's get our ice table out there, and I'm just going to start it right here. So initial concentration of PCl5 is 1 mole per liter and 0 for our products as normal. Change, okay, so change here is going to be minus X. Change for our products is going to be plus X for both. And so at equilibrium we have 1.0 minus X for our PCl5, X, and X. So there we have our equilibrium concentrations, so we can plug it into an equilibrium expression. So let's go ahead and do that. There's our equilibrium expression, and there's our plug and play. So now you notice if I took a square root of that, well, 16, it's 4. So I could do that. X squared is X. I could do that. 1 minus X. So the perfect square does not actually work. And so we're going to have to solve for X the old-fashioned way. And the old-fashioned way is to isolate X, all that sort of business. So you're familiar with that. Coming from this expression to this expression, I'm sure you've done before. Well, maybe not, but you should be able to. It's just straight algebra. This can be tricky, this process. So again, be careful. Use your calculator wisely. And so now we have this equation for the line, and you're familiar with this next item, the quadratic formula. So the quadratic formula will be used to solve for X. And don't forget that you're going to come up with two possible values for X, because we have negative b plus or minus, etc., etc. So you have two values of X. So again, you have to be careful in doing those calculations. And I'm not going to go through that because, once again, I'm assuming you can do it. But what we come up with then is X equals positive 0.95 and or X equals negative 17.0. Okay, so we have those two values, and again, that's a long, very deliberate calculation to come up with the two plausible values for X. Now we can immediately eliminate one of these, and so which one can we eliminate? Well, that's pretty evident. We are going to eliminate negative 17, as you cannot have a negative concentration. I think you realize that. We cannot go less than 0 in terms of a concentration, and that's what X is representing, an actual concentration. So now we know what our value of X is. This is our value of X, positive 0.95. So we just go back to our original variables. So our PCl5, phosphorus pentachloride, was 1.0 minus X. And so the equilibrium concentration of PCl5 is 0.05 moles per liter. The concentration of PCl3 is the same as the concentration of Cl2, which is our value of X, or 0.95 moles per liter. And so there we have our three equilibrium concentrations. And that's how you do it. Sometimes you just have to go to the quadratic formula and solve it carefully, pick the correct value of X from two possible values, and then you can find equilibrium concentrations. So that concludes this video.